Hey everybody, I don't know if I'm going to actually do a video here, but I was documenting signature analysis for Williams boards, and this is my Sinistar, which is working, or at least it appears to be working. I don't have the soundboard hooked up, but I was just going to verify the signatures that I recorded on my Robotron board worked correctly, and then I powered up the Sinistar board, and I do get a weird reading on this LED and some garbage on the screen here when I hit reset. So if I show you that, it'll say 0. I think there's 0. It says all systems go. Then this little blue screen comes up with, looks like corrupt data, probably in, what is it, like the CMOS or some chip like that. It's probably this one right here, this 55514 or something. I think it's this one. I don't know, I'm gonna have to look at that. And then I get that weird error. But maybe that's because the soundboard is not hooked up. I don't know. I just figured I'd document this real quick, and I'm gonna verify some signatures and stuff and verify some of the behaviors I was seeing earlier. But I'm going to use only the HP 5005, so, and that's it. So I just figured I'd do a quick intro in case there's something interesting in this video I end up wanting to share it with you guys. I'm just video documenting this. So in the directions that in the directions that I wrote down, the first thing you need to do is disable the watchdog and either cut the pad between 5H and 5I or ground 5I pin 6, and that is the watchdog pad right there. On this board it happens to be cut right now, but I would recommend just doing a jumper between chip 5I pin 6 and ground. That will disable the watchdog timer. I have vector collectors, no operation adapter there. I have my start and stop wired up, my clock, and my ground obviously to the no op adapter. And in this case, I have the ROM board disconnected because I wanted to verify and document something real quick. So the ROM board is disconnected. I could disconnect the interface board as well, but it's not a big deal. So it's just really the CPU board that is running right now. If you look on the screen, you just get a standard kind of screen like that. Usually you'll see some cycling, but that might be because the ROM board is disconnected. I don't know. So there's definitely signals coming from the ROM board that we'll need eventually, but what I wanted to document is pin address line 15 is 0002. My clock, start, and stop are all configured on the rising edge. So I get 0002 with my HP system. In my previous video when I was doing on the Joust, I was using my K and K and getting weird signatures and stuff, but for whatever reason it's definitely easier for me to get the expected 00, basically 0002 signature on address line 15. And the first thing you want to do is just, I think on the CPU, is I have it documented here, is I just go around and make sure all my address lines have the right signatures from the CPU, and then we can go and start testing the address bus itself. And basically you're going to go to chip 1D, go to this pin, verify the signature, and I just put in what the chip number is, or the chip ID is, what signal you're testing, what on what pin, and what the signature should be. So it's pretty simple. We need to go to 1D, which is, where's 1 at? I think this is that's A, B, C, D, I think. A, B, C, D, 1D. Maybe that's 1D. And we'll find out when we put our signature on there. So 1D pin 3. Let's see here. 1, 2, 3. Well, I'm not getting it. That can't be it. A, B, C, D. Maybe this is Nope, that's not it. Let me figure out what on this board. So this is row, this is A, B, C, D, and this is row 1 over here. So pin 3, 1, 2, 3. Right there, it's toggling, and we get P763, and that's what we're supposed to get there. So basically, I'm not going to film all this, but I'm just going to go through, follow my directions, and then verify my signatures are the same. All right, I got my first thing that did not work as expected. So basically, I'm doing the decoder, the pseudo address line, which is this decoder chip here, decoder 4, and it should be programmed the exact same as the other one. And we go to pin 9, should be UC27. If I go to pin 9, that is 12, 11, 10, 9. I get 4C2H. So, and that's with the ROM board disconnected, and I haven't looked at the signal, so I'm going to power off, connect the ROM board, and see if that fixes my issue, because there's definitely signals coming from this ROM board back in to into the CPU board that could impact the signatures, obviously. So let me do that. Connect the ROM board connected. I got the ROM board connected. You can see that I'm on my screen. I'm getting this cycle of stuff happening, probably because the RAM is being read to or something, and I'm getting something going up on the screen, whereas before it was just static image. Here I get getting something cycling through there. And we're going to go to pin 9. Pin 9, let's see, 12, 11, 10, 9. UC27. UC27. So yeah, so and this is with a different ROM board, obviously. So the signals from the Sinistar ROM board, that's, you know, I think I don't know if I should cover this or not, just for documentation's sake. But basically, there's like 5 signals that come from that get created on the ROM board that drive the enable pins, basically, and the address decoders of the CPU board. So that is probably impacting this decoder. So I don't think I'm going to do 2 sets of signatures with the ROM board disconnected and the ROM board connected. I would say, just if you're doing signature analysis, you probably should have the ROM board connected if you want to do a lot of anyway. Let me think about how to phrase. So to test the video address bus, and Williams calls it the video address bus, but really it's the horizontal and vertical counter chain, I guess. I think it is. Anyway, basically you want to move your clock to this W3 jumper right here. So this is a 4 megahertz clock, and we're also going to move our start and stop to 5G pin 11. So that's 9, 10, 11. And I have this documented here. It shows you start, stop, all on the rising edge. And then we're going to probe these signals here. I have the ROM board disconnected. And let's just see what we get on our first signature, chip 5F, pin 15. That should be pin 15 right there. Okay, I get something different than I'm expecting. Let's see, that's A, B, C, D, E, F. That's 5, 9, 10, 11, 12, 13, 14, 15. I'm getting 0, 1, 0, 2. And I'm expecting, if you can see that, 0, 1, 4, A. So that is not looking good. 5, 5, H1. So let me hook up my ROM board and see if that's making this different as well. I'll be right back. I have the ROM board connected, and I'm still getting different results. Or I'm getting the same results. So the ROM board, as I would expect, has nothing to do with this. And my VCC signature is also wrong. UP73, and I'm expecting 1FA8 for my VCC signature. So I need to double check my settings here. make sure I'm actually getting 4 megahertz clock right here. Let's put that on kilohertz. Yep, I'm getting 4 megahertz clock, so that's not the problem. I'm wondering if I have this hooked up wrong, if this is the wrong chip, so let me double check that and come back. Okay, I found my issue actually. I had it documented wrong. I should read my own directions a little bit clearer, but basically I had it, our start and stop hooked up to 5F pin 11, and it needs to be 5C11, which is the video address line 13. And basically this is the section of the schematic, this counter chain. I'm not going to go through it. Hopefully you can see it somewhat well, but basically it starts with 4 megahertz clock coming into 5F, and then it starts to count down and goes like, 2 megahertz, 1 megahertz, and so on and so forth. I actually measured all the frequencies here. These are all the video address lines. So it starts at VA0 being around, what is that, half of a megahertz, I guess. Yeah, but before VA0 is actually 2 other lines on 5F, because VA0 starts at Q2, and so at Q0 we're at half of the 4 megahertz clock, so 2 megahertz, then 1 megahertz, then half of 1 megahertz is 500 kilohertz, right? Yeah. And then 250 and 125, basically 62, half of that, 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 and then you get to 60 hertz all the way at video address line 13 at 5C pin 11. So that's what we're hooking up to, is the basically most significant address bit in the counter chain. And then there's like ripple carryouts and stuff that's, has all 4 of these counters acting as a chain basically. So anyway, I have it set up correctly now, and I was measuring signatures and everything was checking out except for this one right here. I recorded 5CHA, but that might be a typo. I might have put that in wrong, because I'm getting 56HA at 5F pin 11, which is what we're actually hooked up to right now. No, I'm at 5C, so 5F pin 11 is right, I believe here, 9, 10, 11, yeah, 56HA. So I'm going to have to go back or have somebody else verify that, but I'll update this. This is the one error that I had, so everything else is correct, my VCC signature and everything. So video address bus is checking out okay. The other thing I figured out was about, and I'll go back and verify this again, but I figured out why I was getting some weird signatures when I didn't have the ROM board connected. So if I come here to the schematic here, there's basically 5 signals that come from the ROM board. This, not when HU, so that's something like high upper and high lower RAM banks. I think it's like a read-write signal or something like that. This screen control, this IO signal, and this RAC NT signal. So all of these signals come from the ROM board. Oops. And what was happening, if you can see my cursor here, is this on 3G, which is the decoder for your pseudo video address bus. Decoder 4, basically address line 8 is from, I don't know why it keeps doing that. Let me get, there we go, little pointer. Okay, screen control, this signal here basically holds this low when the ROM board's connected. This address line 8 is low. When it's not connected, it was floating, not completely high, but it was floating a little bit. It was getting about a volt, so this address line was floating up, So anyway, I'm going to put it in the directions. If you ground this address line, we will be able to get good readings on all these pseudo address buses. And then on I don't know about 4G though. I have to check this RAC-NT line and make sure that that's you know, that enable doesn't impact the signatures of some of the other stuff I'm doing. So anyway, I'll double check that, but it's important if your ROM board's disconnected, we gotta figure out, verify what these signals are over here. So just documenting, and eventually I think I'm gonna be able to determine what's going on. I think I have some bad like CMOS or something going on there that is addressed, and I'm hoping that I can use signature analysis to actually fix that issue. Don't know what this LED, why that's bad. If it's related to that CMOS, I doubt it, but maybe we can figure out something over here too. So just documenting, guys. All right, I'm going to take a break from doing signature analysis stuff, and I actually have these 5114 NVRAM modules to replace that CMOS, so I don't need actually a battery. So I don't know if that, let me just, here you go, hold on. There you go, this game's playing, I'm gonna hit reset. And I don't know if it's because of the switcher that it's, you know, corrupting the CMOS. I'm gonna replace it anyway, so I figured might as well. You see, with those digits there, that's kind of weird, right? Not sure why that is, but I'm going to replace it anyway, just to see, because I was, you know, I want to put in the NVRAM adapter. Could still have a problem by using the switching power supply, but I figured I'd do that. Disconnect this board. It'll also give me a chance to potentially put my joust board back on and verify a couple things. So, all right, we have got the NVRAM all put in there. Wasn't too bad. I lifted up a insignificant pad that didn't go to anything, but gotta be careful on these Williams boards, man. But I wanted to save it because I might test it in my NeoLoch. All right, what are we doing? Powering on. Got a 0. All systems go. Bookkeeping restored. So let's hit reset. All systems go. Well, now I got different weird characters over there. So maybe it's not the CMOS. The characters are somewhat different. Let me see if I power it off, if it'll actually save the... If it comes up with that bookkeeping error message again. It could be due to that switching power supply, potentially. Well, it saved the settings, but I still got some weird junk going on there. Weird. Wonder why that is. Alright, I don't know if I'm gonna... Still got that error there, too. Wacky. Alright, this is my this is my Sinistar board. This is my joust board here. But as I've shown in previous videos, Williams boards by default put out positive sync, and you can cut this trace here. I think it's like W2 or W1 or something. I don't know what the jumper is. Excuse me. But I'm tired of removing this jumper and cutting the trace and stuff. So basically what I'm going to do is take this 7404 LS04. I'm going to hook it up to my adapter. I don't know how I'm going to mount it yet, but I'm basically going to run ground and power to it, and then take my sync from the Williams board, run it to pin 1, and then it should invert that output on pin 2. So that's what I'm going to do here, and I'm not going to film everything, but basically mount this thing here, run power, ground, take the sync circuit, composite sync circuit from the Williams board, run it to pin 1, which is right there, and then run pin 2 out to my monitor. Okay, so I don't know if this was a great idea, but I basically just bent the ground pin over and soldered it into the ground hole on this Ian Kellogg adapter, and then I wired 5 volts pin here, looped it around to 5 volts there, and it's exposed. I probably could have done a little bit better job, like actually feed it through the hole. I don't know, whatever. Then I took my composite sink, sorry about that, composite sink, and I ran it through this hole from the top side. I don't know if that's a great idea. 12 volts is running through that, but it is insulated. I think it should be fine. And I could have just wrapped it around, obviously, but I don't know, this seemed like kind of a good idea at the time. And then took the output here, pin 2, input into pin 1, output of pin 2, ran that to composite sink. So I'm going to power this up and let's see, hopefully I don't fry anything. All right, there's my little JAMA harness, JAMA adapter. I had reworked actually my JAMA connection with better JAMA connector. I was using something that had not a big enough gauge wire, like those cheap Chinese JAMA. So I used better JAMA rig. So now I actually don't need to hook up extra power connectors if you've been watching other videos. But anyway, all right, got it hooked up. Let's see what we get. Well, looks like we got sync. It's working. So that's good. That was a success. All systems indicate go. Factory settings restored because this is my joust board. Let's hit reset. Okay, so we know something is going on with my Sinistar board that's not in CMOS related. But that error is still the same. So something's going on the ROM board related to that, and there's something on my Sinistar board related to the CMOS that's causing that not to work correctly, I think. Here, let me power it off. Power it back on, see if we could save settings. Yep. I get good data in my high score table there. So that's weird. So definitely something going on with the circuits on my Sinistar board feeding the NVRAM. Interesting. Alright, be back. Alright, just so I wasn't chasing my tail, I put my Sinistar board in my joust cabinet. And let's see here. And it's saving scores fine. See, how can I tell? I'll just power it off. And I think it has to do with that CMOS getting corrupt because I'm powering it off while I'm running a no-op adapter on it. I think that's what might be happening. So you can see that the high score table is fine, and it's also saving. I set it to free play, and it's setting high scores. So anyway, false alarm on the CMOS thing, but I did have to replace it anyway to get NVRAM on there. So maybe I'll do some more signature analysis on some other stuff here, but NVRAM's fine. All right, I'm just filming random stuff because I think when I started this video, I had my video address hooked up wrong. Did I come back and fix that? I have no idea. But anyway, I had one signature written wrong. This is my joust board. This is on the video address bus or the horizontal counters, and I needed to verify 5F pin 11. 5F, I think A, B, C, D, E, F, 9, 10, 11, 5, 6, HA. So I had that written down wrong. I need to fix that. So that's good. I don't know if there's a lot to do. I think I still haven't documented the ROM signatures And there's some other stuff I can try to do with RAM maybe. I don't know, I'm losing steam on the signature analysis stuff, but I might come over and do the ROMs at least. Alright, just to see if doing the signature analysis was actually putting weird stuff into the NVRAM. I set it back up. This is still the joust board. Plug it on, plug it in, turn it on, whatever. Let's see what happens. It says all systems go. Huh. Looks normal. What the hell? Weird. I guess I'll come back and I'll put my Sinistar board back on here that was working fine in my joust and see what it does. Seems weird. Interesting. Yeah, it's playing fine. And then I still got that weird thing going there on the LED. Not sure what that's about. Alright, got the Sinistar board back in there. Let's power it on, see what happens. If our CMOS is corrupt again, or what the heck's going on there. Factory settings restored. That's because I came from the Joust ROMs, the Joust ROM board, back to my Sinistar board. So we have to reset it. There we go. Okay, now I have data. I don't know what's going on. I don't know why it was screwed up before, but it looks like it's fine, I guess. I don't know. Should I test that? I might test that 5114, that other RAM. Alright, so it is a, gosh, if you can see that, it's a 5514. That should be compatible with 2114, 6514, 9114, and obviously these 5114 NVRAMs from, I think that's Pentec is what I was using. Oh, there we go. Pentec. Alright, so let's test this thing. Oh, it says it's bad. Very cool, so I guess it was a bad CMOS chip. Interesting. I wonder if I test one of these NVRAMs. I don't know how much I paid for these. Hopefully I don't ruin it. Do I have it? Hopefully I also have it plugged in correctly. Let's see here. Oh, I can't even. Yeah, there we go. Alright, let's see. Okay, it doesn't like that. Doesn't like that either. Is this really bad? 5514 testing as a 6514 should be fine. Haven't used my NeoLoch in a while. I'm wondering if the NeoLoch can actually test these okay. All right, this is a 2114, just verifying that it can work. I had this in my spare parts. Alright, the 2114 works fine. But this 5514 does not test fine. Oh, okay, I just moved it to make better contact with the thing there. That sometimes happens if you have the this ZIF socket. If it's not making good contact with the legs, you just kind of like give it a little push while it's latched in there. So yeah, it's fine. Interesting. I guess it can't test the NVRAMs. Same thing with this here. I put my NVRAM back in there and just slid it in the ZIF socket. I might need to get a different ZIF socket. I put a better one on one I built for somebody else, and this ZIF socket, this cheap 3M Chinese knockoff thing sucks. I mean, there's no reason why I would have to slide it around in there, but alright, so I can test the NVRAM PinTech ones too. Alright guys, I'm wrapping up this video. My Sinistar is obviously working, thank God, I guess, or it's working. I'm curious about this little couple things on there, like that little jumper there, this LED. I'll come back to that in a different video. This video is already about 30 minutes long. I will also link to the thread that I'm doing on the signature analysis if I haven't linked to it before. I really added a whole bunch of stuff to it, and but eventually I would like to finish my Sinistar cabinet. Got a couple repairs to do and bring it back in the basement because I won't have a board to actually work with. But that's it for this video, guys. Thanks for watching. Just a random bunch of BS. But I did accomplish one thing, which is do that little mod on my Williams JAMA harness, so I do not have to cut that trace right there. So out of everything I did, beyond a bunch of waste of time of signature analysis on a working board, I did actually at least do that, and also from PinTech the 5114 NVRAM mod. So alright guys, that's it. Have a good one. Till next time. Bye.